Good afternoon, everybody. It's very nice to see you all today. Thank you for coming. So this week is, of course, World Space Week, as you all know. And what we've got today is an Ask the Experts Icy Moon edition. Now, this is organised by AstrobiologyOU at the Open University. If you have any questions along the way, you are more than welcome to ask our experts. And there is, if you look at the bottom of your screen, there should be a Q&A button. Click on that and put your question in, and we will try our best to answer that for you all when we get to a question section a bit later. Now, my name's Claire. Just to introduce you to myself, I'm a postdoctoral researcher in AstrobiologyOU, and I use special equipment which is a bit like a big nose. So it sniffs out molecules and signs of life, and hopefully it will tell us one day if there is life on other planets, or if there was life on other planets, or molecules that show the signs of life, and of course places like icy moons. Now, I've got three other lovely colleagues with me today to introduce you to, who all work in AstrobiologyOU and study the icy moons. So first of all today, we've got Mark. Mark, can you come and introduce yourself to everyone?
Hello everybody, I'm Mark. As Claire said, thanks very much for the introduction. I'm a research fellow here at the Open University, and I'm lucky enough to spend my time studying these amazing, fascinating objects out there in the solar system that we'll be talking about today. So in my work, I use a bit of a mix of experiments in the lab, in the laboratory, where we actually can simulate the conditions that we think might exist on these worlds, and kind of try to understand bits about the chemistry and things like this. But I also sometimes go out into parts of the Earth. I do field work, so I go to, especially to kind of cold places in the polar environments, places that we think might be similar to these planets, these moons. So yeah, that's me.
Thank you, Mark. Now next we have the lovely Grace. Would you like to introduce yourself to everyone, please?
Hi, I'm Grace. I'm sorry if I sound a little bit croaky. I'm a bit poorly today, but I am a PhD student at the OU, and I work in the astrobiology department, and I study Enceladus, which is one of the icy moons. And mainly my work consists of building things in the lab where we can replicate the conditions on icy moons and then try and grow ices which we find there. So that's what I'm working on at the moment, hopefully building some equipment and then testing out whether or not we can fire things at them and simulate cratering and impacts, and trying to figure out what is the best way to do that. And that's pretty much what I do.
Thank you, Grace. And last but very much not least, we have Al. Al, would you like to introduce yourself to everyone?
Hi, my name is Al. I'm also a PhD student at the Open University. I'm a microbiologist. That means that I study organisms that are very, very tiny, that you cannot see with your naked eye. And I'm trying to figure out if those organisms can live in extreme places outside of planet Earth. And my focus is in the moons of Jupiter, but we'll talk about that later.
Thank you, Al. So we have some really amazing pictures to show you today, which we're going to chat about. And remember, any questions, just pop them in the Q&A and we'll answer them. So we've our lovely first picture. This is what we're talking about today, which is, of course, the icy moons. So we're going to have a little chat, and hopefully they'll explain lots of information about these moons.
Okay, so what you can see in this picture here is a little selection of some of the icy moons. And on the side, we've also got Earth. So what makes Earth so special for life is we have our oceans and rivers and lakes, and there's everywhere that we find water on Earth, we pretty much find signs of life. So if we're going to be looking for signs for life in our solar system, we kind of want to follow where the water is. And that is why we all study icy moons. Because even if on the outside of the moon it's covered in ice, beneath the surface of the ice, we have these deep subsurface oceans. And we think that they could be a really good place where we can search for signs of life. So on the top here, on the top row, you've got some of Jupiter's moons. So that's Europa, Ganymede, and Callisto. And these are all icy moons of Jupiter. And they're quite big for some of the moons of Jupiter, because Jupiter has absolutely loads of moons. And then on the bottom, we have some of Saturn's moons, so a bit further out than Jupiter into the outer solar system. And here we can see Titan and Enceladus. And as I said, what makes all of these moons so special is we think that they have these oceans beneath the surface ice, and we could potentially look at those oceans to see whether or not life could be possible there.
Wow, these moons are just, I think they're really pretty, most of them, aren't they? Does anyone think that these moons are something that we can look at in a bit more depth? I think Al can explain a bit to us about the actual structure within the moons. You're muted, Al, sorry.
Sorry, I was just saying the most common structure presented is usually looks something like this. So this is just an artist's rendition. It's not a real image. But if you were standing kind of on the surface and you were able to look down on one of these moons, this would be something that you would see. You could see through the surface. So up here, we can see Jupiter and another of its moons in orbit. And then you can see all the cracked ice. So there's usually a layer of solid ice. And underneath that ice, there's a water ocean, liquid water ocean. And we believe that in many of these moons, this water ocean might look very similar to the one on Earth. And then if you go down, really down deep into the ocean, you'll find what is known as hydrothermal vents. These are just like volcanoes, just underwater. They're a little bit different, a little bit special, and they release all kinds of stuff into the ocean that might allow life to exist in these oceans. This picture is not to scale. So generally speaking, we can find all kinds of depths, all kinds of widths of these layers. So yeah, just keep that in mind.
One thing it's worth pointing out is that we have these kind of hydrothermal vents on Earth in the deep parts of the ocean, and we've gone to explore these. I don't mean us, but lots of people have, scientists have, and what we found is that life can actually persist down there completely in the absence of sunlight. So you have these amazing forms of bacteria that can harvest energy from the chemicals coming out of the hydrothermal vents. And then you have other small animals that kind of eat the bacteria. And you have this whole community, this ecosystem that functions completely without sunlight. So these kinds of moons get us really excited because these hydrothermal vents on Earth show us that life is possible in that type of environment.
So can you tell us, are these hydrothermal vents, are they, in the scheme of things, warm or cold right down there at the bottom of the ocean?
So we believe that they are warm, but quite warm in some cases, so above boiling temperature. But because it's underneath all that water, the water ocean, the water doesn't boil. It just stays really warm. It doesn't get to boil. So there's this gradient of temperatures down there. So organisms, life that might like it a little bit warmer might be closer to the hydrothermal vents, or they might be a little bit further away. So yeah.
Oh, can I just say this picture is amazing, and Al did it digitally himself, so I think it makes a lovely picture of the layers of these moons.
Sorry, Claire,
go on, Mark. No, go on, Mark.
I wanted to say something else, actually, going back to the last image, if I can, just a second.
Yeah, please do.
One thing that people don't quite realize is how much water we're talking about. So you can see Europa here on the top left. So that's a moon of Jupiter, and it's drawn here in the picture here. It's at the same scale as the Earth. Of course, these moons aren't actually this close to the Earth. They're a lot further away. Europa is in orbit around Jupiter, which you can actually see some nights, a bright star. But Europa is about the size of our moon, but it has more liquid water in its oceans than all of the water on Earth's surface combined. And that's just because it's a really deep ocean. We think it's about 100 kilometers deep. of just that water, with, as Al was saying, those hydrothermal vents right down at the bottom. So yeah, quite an exciting, big volume of water that could potentially have life in it.
If I could just add to that as well, if you think about that to scale with the Earth, so Europa is the size of our moon pretty much, it's got 2 to 3 times the volume of water on Earth potentially. And Mark was saying it's about 100 kilometers in depth. Our oceans on Earth are only on average about 4 kilometers. So you think how deep the ocean is, it's pretty scarily deep, right? And even in the deepest places, it's about 11 kilometers deep, whereas Europa, 100 kilometers, that's 10 times the size of our oceans on Earth, which is quite a lot of water to be looking at.
Mm-hmm.
That is definitely a lot of water. But of course, with all these beautiful moons, we have to ask our lovely panelists which one is their favourite, because we all have favourites. So, Grace, would you like to tell us which your absolute favourite icy moon is, please?
Of course. So my absolute favourite is the one that I study, and that is Enceladus. And it is one of Saturn's moons. And the reason why it's my favourite is because it's so small. So this moon is only 500 kilometres in diameter, so across, and that is roughly about the size of France. But even though it's so small, it shouldn't go unnoticed because it's actually the smallest active body in our solar system, which means that there's a lot of heat generated within the interior. The surface is kind of cracked, so you can see that there's things going on beneath the surface, which is worth, studying more. So here is a picture of Enceladus, and the surface is mainly composed of water ice, so exactly like you'd find on Earth. But underneath the surface, because of a space mission which went out there fairly recently, we now know that there is a subsurface ocean underneath it. So in the South Polar region, so the South Pole of the moon, there are these huge fractures in the surface, which are called tiger stripes. So these are called tiger stripes because it's as if a giant space tiger has clawed the surface, and then this allows material from the ocean to get ejected into space. So you've got the ice, and then beneath that, you've got this huge ocean. And all of that can kind of leak out of the moon into space. And these are called plumes. So I think if you move on to the next image, Mark, we can have a little look. So you can see right at the bottom of the moon here, there's all these little jets of material. And in the South Pole, there's potentially up to 100 jets which eject this material from the ocean thousands of kilometers into space. So this is important because when we send space missions to Saturn to study Enceladus, one of its moons, we can actually get a little taste of that plume material and find out what is going on beneath the surface ice, like a little taste of the ocean. And we've actually done this, and analysing that material, so all this little ocean material that's now in space, we get a little taste of it. And that has led to the discovery that, like the hydrothermal vents that Al and Mark were talking about, we think that that's actually happening on the seafloor of Enceladus. And this is important because on Earth, we think this is potentially where life has originated. So if this is happening on Enceladus as well, potentially there could be life on Enceladus. And that is why Enceladus is my favorite moon. It's so small. There's the tiger stripes, which, you think of space tigers. I think that's pretty cool. We can actually look at the material that comes out of the ocean because it's being ejected into space.
One very cool thing about the Cassini mission, which is the space mission Grace was talking about, that actually studied these plumes and studied Enceladus. They didn't know that Enceladus had these plumes until Cassini actually got to Saturn. So they'd obviously taken pictures of Enceladus before from different spacecraft and things and telescopes, but the plumes, we didn't know that they existed. So when Cassini arrived and took these pictures, they were kind of mind-blowing. It was this amazing discovery that this moon is so active. And it was only because Cassini had these special instruments on board to study other dust around Saturn that it was able to actually take a sample and taste that ocean like Grace was talking about.
So do all these plumes go into space? Does anything go back down again?
So this is kind of what I study. So I study the surface of the moon, and most of the plume material which gets ejected out from the South Pole actually goes back to fall onto the surface, which is important because that means that the whole surface of this satellite or moon is potentially covered in ocean material. So again, you could send a space mission there to directly look at what's being ejected, or you could land on the surface of the moon and potentially find out what's going on beneath the surface, just because all this material kind of gets put back onto the surface. And the rest of this material actually goes on to feed one of Saturn's rings. So if you think of Saturn, it's that big planet with loads and loads of rings around it. And one of these rings is actually fed from Enceladus. So all of that material in the ocean, all that icy material gets ejected out. Some of it gets to fall back on the surface, and then some of it actually goes on to feed the second outermost ring of Saturn, which is huge. It's a really big structure. So this tiny little moon, the size of France, is actually helping to maintain Saturn's rings, which I just find incredible.
Can you all see that picture?
Yep.
Yeah.
So that is what Grace is talking about. It's an amazing picture. This is a real image of Saturn. It's being lit up from the back by the sun. And that kind of wispy, cloudy ring that you can see that spreads out a long way from Saturn, that is the ring that Grace is mentioning, that is actually formed from all this ocean material coming out of the plumes of Enceladus.
Very beautiful, I think. What about you, Mark? What's your absolute favourite icy moon?
Well, that I have to turn into another one of Saturn's moons. I'm just going to get a picture of it now on the screen so we can talk about it. Just a second. This is Saturn's moon Titan. So we're going to the opposite end of the spectrum now. This is the largest moon in the solar system. It is a planet-sized moon. It's actually larger than the planet Mercury, and it's one of these icy moons, just like the others, just like Enceladus. It has an ocean. It has a surface that's made of water ice, and it has an ocean underneath that water ice, very, very deep ocean, where we think it's possible that life could exist. But actually, what makes Titan really, really special and unique is that it also has an atmosphere. It's the only moon in the solar system to have an atmosphere. And we're very familiar with atmosphere here on Earth. You're breathing it now. As you breathe in and out, that's the atmosphere. The air that you're breathing into your lungs. If you swish your hands around, you can feel that air moving around. That's the atmosphere. So Titan actually has a similar atmosphere. It's about the same thickness, so it would feel quite similar in some ways. And you can see it in this image. So I don't know if you've ever seen pictures of the Earth from space. You'll see this kind of blue haze just over the surface. That's our atmosphere. And you can see something really, really similar in this picture, which was taken by the Cassini spacecraft. And you can see that blue haze that covers the moon. And actually the surface, which is all made of water ice, is actually kind of slightly obscured and hidden away. Now, the crucial difference between the Earth's atmosphere, that we're very used to, and Titan's atmosphere is that Titan's atmosphere is actually very, very, very cold. So your freezer gets down to about minus 20 degrees centigrade, but the temperature on Saturn's moon Titan is something like minus 180. So it's much, 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 much colder than your freezer, and it's obviously a lot colder than anywhere on Earth. And that gives rise to all sorts of exciting things. So a lot of gases that we think of as gases here on Earth actually are liquids at the temperatures on Titan's surface, and that means they can fall as rain and create rivers and lakes on the surface, just like we see on Earth, but not water. These are actually made of gases that we would think of as gases, things like methane. So I'm going to move on to the next image, and this is an amazing picture, I think, absolutely spectacular picture, and I'll describe why. This is taken again by Cassini, and it's just a Crescent Titan. So it's a bit like you have a crescent moon. This is a Crescent Titan, but you can just see sunlight glinting off a lake in the north of Titan there, and that lake is just like lakes on Earth. It's fed by rivers, but those rivers are formed of liquid methane, a gas here on Earth, and that's because it's so cold. Now, you could actually visit Titan if you wanted to without a spacesuit, and that's because the atmosphere is so thick you wouldn't need a spacesuit, but you would need some oxygen, and of course a really warm coat, because it's minus 180 degrees centigrade. So that's why Titan is my favorite of the icy moons.
Oh, thank you, Mark. I love that picture. It's amazing to think, isn't it, that there's actually lakes on some of these moons. What about you, Al? Do you have a favorite icy moon?
Yeah, one of the ones we already talked about, one of the most popular ones, and it's also the one I'm studying now. That's Europa, the one you can see now on your computer screens. This is the smallest of the moons of the known Galilean moons of Jupiter. So there's 4 big moons apart from the smaller ones. And in fact, if you ever get a chance to look at Jupiter through a telescope, you'll clearly see Jupiter, and then you'll probably see small stars right next to it. Those are the moons. So you can actually see it with a telescope. You cannot see it with your naked eye, but you can see a small star in the sky, and that's Jupiter. You can see it right now. If you look during the afternoon, right as it's starting to go into the night, one of the first stars you can see is Jupiter, and you can notice it because it doesn't twinkle. Jupiter, Europa is one of my favorite moons because of just how big it is compared to Enceladus, for example, and how much water it has. And because it has some interesting stuff. It's locked between 2 of the other moons of Jupiter, and that causes an effect. It's similar to when you grab a piece of metal. Some of you might have noticed that when you bend a piece of metal very fast, it gets worn. That's because of friction, and that's something similar that is happening in this moon. The 2 moons that orbit around Jupiter and are pulling on Europa, and they are stretching and compressing that moon. That not only heats up the interior, which causes the ocean to be liquid, but it also makes the ice a little bit hotter. Again, it's extremely cold. In this case, minus 160, 170. But that causes the ice to crack. And you can see the cracks here. The ocean then fills in these cracks and refreezes. And whatever material was in those cracks gets exposed to the exterior. Europa doesn't have an atmosphere, so all the radiation, all the light that is traveling through the solar system from the sun gets trapped because of Jupiter and falls, it rains down on the surface of Europa. And it kind of, you can imagine it as cooking the surface basically, and making those components, that stuff in the water ocean that is exposed to space to change colors. And you can see it perfectly here. And that can give us an insight at what is inside those oceans, and know a little bit more if it contains life or not. But yeah, that's one of my favorite moons. The next image, here's a little bit more in detail of those cracks. And as you can see, they separate and fill in with water. And we think that we might get one day to visit the surface of Europa with a robot mission and drill down and see if there's life in this ocean. Now, because of the radiation that's on the surface, you wouldn't survive for long. It's not like Titan. So there's no protection that you can wear to protect yourself on the surface. You would need to get under the ice. Now, if there's life in the ocean, that life is protected from the radiation by by that ice shelf. It only takes a couple of centimeters of ice water to block the radiation on the surface of this moon. Yeah.
Wow, it's amazing that the ice can actually protect it like that. So, do we know why it's brown?
Well, we're not entirely sure what components are giving that brownish color. We think it's sulfur. So that's the bad smelly element that you smell sometimes with eggs, or if you've ever visited a volcano or something like that, that bad egg rotten smell, it's caused by sulfur. And there's several compounds of it. And we think it might be one of the compounds that is giving this color, and it's because of it being cooked by the radiation. But yeah, we're still not sure. I mean, we found other things on the surface, or at least we think we found other scientists have found other things on the surface, like table salt. So yeah.
Wow. As Mark mentioned earlier on, we do things like field work and we work in the labs. Mark, can you tell us a little bit more about some of that?
Sure. I'll just move on to the next image. I was just going to say actually about Europa, as well as the sulfur that Al was mentioning. He mentioned table salt, which is obviously it's the kind of salt that you would be very familiar with in your kitchen, but it's also the main kind of compound that's in our oceans. So the fact that we think we see table salt on sodium chloride, this is on Europa's surface, is quite exciting because it hints that the ocean might be really familiar. It might be the chemistry of the ocean might be quite similar to what we see on Earth, which is obviously quite exciting because it means that there's more chance that we're looking at something that is quite close to home in terms of its potential for life. So I'm going to move on now and go full screen again. So can you all see that? Yep. So this is a picture of me actually earlier in the summer doing some field research. Now I did mention that this is one of the ways that I do my research, but it's worth saying, we study these moons obviously through space missions, as has been mentioned a few times, and a lot of the pictures you've seen today are all from space missions. And we also use telescopes, but those kind of ways of actually observing, we call it, looking at these moons, all they do is kind of give us some data, some numbers effectively, and then what we need to do is actually go and understand what those numbers mean. So we need to put that into some kind of context, and that's a lot of the work that we do here at the Open University and AstrobiologyOU. It's all about finding out what that context is. What do those numbers really mean? And so this is one of the ways we do this. I was out in an island called Svalbard in August this year. And this is in the very, very far north of Norway. You'll have heard of it if you've ever read his Dark Materials trilogy or seen the TV show. But this is a real place. It's in the Arctic, and it's a beautiful, beautiful landscape. And up there, we can study types of ice that are similar in some ways to what we think exists on the surface of some of these icy moons. So that's what I'm doing there. I'm collecting some samples to take back to the labs and do some analysis on. And am I talking about this as well, or would Grace like to say anything about this?
I don't mind, I can speak about it if you want.
Go for it.
So what you can see here, so like Mark goes out into the field, he also works in a lab as well, but I only work in a lab. So this is a picture of what I do in the lab. So here you can see this big kind of container, which is silver. And this is a system that I have built to try and replicate these conditions that we find on icy moons. So they don't have an atmosphere, so you need to create a vacuum, which is like the absence of any atmosphere or air. And you also need to get things really, really cold. So here you can see this system that I've set up, and inside that little container, that should kind of be like what we'd find on an icy moon surface. And I use this to grow ices, which are similar to those which we find on Enceladus. So lots of water, maybe some salts, like table salt, and then some other like gases that I put in there as well. And then that is how I create like a mini icy moon in the lab. So just to give you a bit of an idea of some of the equipment that we work with and use and build at the Open University.
Oh, thank you both. It's a lot of different things that are going on, isn't there? And lots of different things we can study. I have to say, thank you very much. We have had lots of questions coming in today. So let's have a look at some of those now. We have one here from Plymouth Grove School. I think it's, I'm guessing it's school, sorry. What happens if these volcanoes seriously erupt? I'm assuming they mean here they're hydrothermal vents, perhaps?
Good question. Al, do you want to?
Yeah, I mean, we think that some of them are constantly erupting. I mean, they're constantly throwing off material. Some of them on Earth have been active for, who knows, decades. Some of them even potentially hundreds of years. You don't have to imagine it as lava coming out of those volcanoes, but rather very, very hot water. It's because the water, there's so much water that it causes the pressure to be very high, and thus the water ends up going into the rock, getting hot, and then being, expelled through those volcanoes. So it's not always lava. It's more like very hot water.
Thank you, Al. Now, before we go any further, what we're actually going to do is put a little poll up for you. So you guys, we'd like you to answer the question, if you can, of which icy moon from the three we've just chatted about do you think you'd rather visit? So if you do that, we'll tell you what answers we get a little bit later on after we've had some more questions. Okay, let's have a look. We've got absolutely loads. Let me see. If you have any more, please send them in, because we love to have lots of variety here. Okay. Oh, this is a good one. Do you believe there is actually life somewhere else, and why?
I'm happy to take
yeah,
this one.
go for it, Grace.
So I studied astrophysics before I started my PhD here and started working more like building things. And the thing that really drew me to it was the kind of size of space. So if you think about it, we live on a really small ball of rock in our solar system, and that is just one planet in the solar system where we've got life. And the Earth is absolutely teeming with life. And we're on this weird little ball of rock and with our one sun. But if we look into our galaxy, there are 250 billion suns in our galaxy. And so that's a lot of potential suns with their own planets. And then, so our galaxy is the Milky Way, and that's just one galaxy. And then if we look even further beyond that, we know that there's about 200 billion other galaxies in our universe, kind of minimum scale. So if you think about those numbers, like billions and billions of stars and billions of galaxies, and we're just one tiny little ball of rock in that whole sea of stars, I kind of think, why would there not be life elsewhere? Because if it's happened on Earth, then potentially it could happen elsewhere. And I think it's something nice to think about as well. Just little us on our little ball of rock, orbiting our tiny little star, but we're part of this like big system.
And to just add to that as well, you think about, this is one of the reasons why studying the icy moons, I think, is really important and interesting, is that if we do discover life on the icy moons, and it has started in a separate way for the Earth, so we had life originate twice in the same solar system, and then you think about how many stars, as Grace was saying, there are out there, it gives a good kind of indication that life is probably quite common. So this is a good reason to kind of go to these places and go and look and see what we find.
Yeah. And I guess as well, like as far as we know, there are quite a few planets out there that are similar to Earth. So even if there isn't life on icy moons, we know that planets that are similar to Earth are pretty much all over our like galaxy. So why not have a look and see what we can find?
Yeah, and not only that, but we are made up of some of the most common elements in the universe. So the recipe that makes up life on Earth is the ingredients are all out there. We found it everywhere. They are the most common elements in the universe.
The last thing I'll say is that all of that sounds, it's very hopeful about finding life, but of course we don't actually know how common life is, and that's actually one of the really exciting things about this kind of science. It's a big mystery right now, and we're just trying to find out. We're just trying to understand kind of our place in the kind of wider living universe. How common or rare really is life is. Yeah.
Excellent. So we have another question from Atfield House Care Home. Hello, back to you. The residents would like to know if there are any plans to land a rover like Curiosity on Mars on any of these moons in the future. Yep, go on, Mark.
I want to take this because I actually have another picture I would love to show, and I think it's really, really cool. So the answer is yes. There's actually a few plans, and somebody else might want to speak about Europa perhaps, but I just wanted to flag up my favorite icy moon again to show you this picture. So this is a spacecraft called Dragonfly. Can you see that? Can you nod? Yeah. Yep. So this is obviously an artist's impression. This is not a real photograph, but this is actually a kind of drone. It's a quadcopter that's going to fly in the atmosphere of Titan next decade. So I think it's going to be launching later in the 2020s, and it'll take a few years to fly to Saturn. And when it gets to Saturn, it will deploy and land on the surface of Titan. And I was mentioning that thick atmosphere earlier. Well, that's good because that means we can actually fly. So this is a drone that will fly around on Titan, so it can explore a lot of the surface and go and find some of these lakes I was talking about and take samples and sniff the atmosphere and do all kinds of exciting stuff. But actually seeing this fly around will be really, really cool. I don't know if any of you have seen pictures of the Ingenuity, the little drone helicopter that's on Mars right now. So this is going to obviously be a little bit bigger and a lot further away, but use a lot of the similar kind of approach.
Another mission that I'd mention as well is we've got 2 missions going out to Jupiter soon. So NASA is going to send a mission called Europa Clipper, which is going to go directly to Europa. And then the European Space Agency has got JUICE, which is going to be launched potentially next year. And JUICE is an icy moon explorer mission. So I don't know if Mark's got any pictures, but both of these are going to study the icy moons of Jupiter. So like Ganymede, Callisto, Europa, and really search for signs of life. And something that's still in a concept stage at the minute, but has a big team behind it, is the Europa lander. So hopefully after NASA have sent out the Europa Clipper to go and do a flyby and kind of look at where potential landing sites are, get more of an idea about Europa's surface and where it'd be safe to land, there'd hopefully be the Europa lander out of there, which could land on the surface of Europa, scoop up the material and analyze it and get a direct sample from Europa. So that's kind of more Jupiter system things that are going on. Here as well, you can see Cassini, which is the mission that me and Mark have been talking about quite a lot, which went to Saturn. You can see just on the picture on the right here, you can see all the people in their little bunny suits, kind of, I don't really know what they're doing, putting it together, testing it. But you can see the scale of that spacecraft really compared to the little human beings next to it. And then you've got an artist's impression on the left there of the Cassini mission. But it takes like 7 years. It took Cassini 7 years, I think, to get to Saturn. So these missions get launched, but then we don't find anything out for nearly a decade. So we want to start sending them off pretty soon if we want to get more data.
Yeah, it can take us a little while to get it all back, doesn't it?
And the amazing thing is, this Cassini, I think the picture on the right-hand side here, was probably taken in about 1995 or 1996. And I was in school then. But now, by the time, you know, these missions take so long to fly to the outer solar system and then take all of their measurements, you know, now my job now really wouldn't exist if it wasn't for this mission. So it's funny to see that, you know, a photo of this spacecraft on Earth before it left the Earth while I was still in school. And now it's kind of come full circle, and I'm working on science that has been made possible by measurements taken by Cassini. So these missions have a long lifetime, and it's possible that some of you might be working on measurements that are taken by Dragonfly or one of the other missions that Grace mentioned that are launching, you know, this decade.
Yeah, future scientists, get ready to go and take your measurements. So we have another really good question. Could we swim in Europa's waters?
I mean, it's underneath a 20-kilometer layer of ice. So first you would need to get there. And after that, you need to consider that the pressure is quite high. But near the surface, you might be able to swim, quote unquote. In fact, for the far future, they're planning on even visiting the ocean with some kind of robotic mission. But yeah, if maybe near the surface with a nice, you know, scuba diving suit, maybe.
Very cold, I should imagine.
Yeah.
Was it called Titan because it's the largest moon in the solar system? That's
I think
the question.
Yeah, I think it might be. I think so. Yeah, I mean, all of the moons are named after sort of characters from Greek and Roman mythology, as you've probably noticed. So Titan, yeah, absolutely. The Titans, massive creatures, and I think that's really fitting for the largest moon in the solar system. Although I will point out that it depends how you class largest, because Ganymede, which is, we mentioned at the very beginning, it's another moon of Jupiter. In fact, it's another icy moon that has an ocean, and we haven't spoken about it today, but it's another one that's very interesting. Ganymede is very much the same size, and it's only Titan's atmosphere that makes it slightly bigger. So it depends how you count largest. If you think the atmosphere should be counted, then Titan's larger. But if you think that the atmosphere shouldn't be counted, then Ganymede is actually slightly larger. But yes, I think you're right. Titan is probably named because it's the largest moon.
So we have a nice question here from Beth. Would it still be possible for life to survive on Europa and other icy moons without an atmosphere?
Yes, because the ice layer is acting as kind of an atmosphere. It's protecting it from space, and it's giving it a little bit of pressure. So the ocean is liquid, and it has very similar conditions to the ocean on Earth. So from the bottom of the ice layer down to the ocean floor, you have different temperatures. You go from 0 degrees where it freezes up to the hydrothermal vents, reaching temperatures that we're not exactly sure how high they can go, but 150, maybe 400 degrees, even on the upper limit. So you have all kinds of conditions where life might exist. We've talked about life being near the hydrothermal vents, but another idea is that they might be living right underneath the ice layer, and they are being fed by all those materials that are being cooked on the surface of Jupiter, and then they end up, being refrozen and end up in the ocean. So yeah, there's a lot of possibilities for that.
Oh, excellent. We have a really important question here from Andrew. If there is life elsewhere in the solar system, can we detect it without contaminating its ecosystem?
Great question. And this is actually it's a real concern. And I think for a few reasons. One is, obviously, we need to know that the samples we're taking are clean, that we're not just, if we're looking for life, that we're not just detecting the life we brought with us. So it's a kind of scientific problem on some level, because we just don't want to contaminate our samples. But also we have this concern, you know, what we've done on Earth a little bit is kind of spread and spread things around. We have invasive trees, we have invasive animals in certain parts of the world, and we've changed habitats quite a lot by our activity. And we really want to be careful about doing that again if we go to some of these other moons. We don't want to accidentally introduce lots and lots of Earth bacteria, let's say, to Europa's ocean. So absolutely, it's a big concern. And when we design spacecraft, they have to go through these really kind of stringent, these really strict processes to clean them and make them ready for flight. So for example, the ones that land on Mars, they have to be very, very clean, because they're landing on a planet that potentially could support some forms of life now. So we need to be very careful about these things. And any mission, as Al was saying, that might end up drilling through the ice to get down into that ocean, you know, that we have to be very, very careful about that. So yes, absolutely, this is an area of a lot of research and thought at the moment.
Yeah, on Mark's lovely picture that he had of the mission with the Cassini, there, like Grace said, there are people in all those white coats. That's basically not to protect the people, but to protect the equipment from anything that people have on them as well.
But actually, the question was, can we do it without contaminating? And I think yes. I think we do that on Earth already when we go and sample certain types of extreme environments or environments in Antarctica, in the deep oceans now. We know how to do that in a way that is clean, and that we can be sure that what we're looking at is really a sample from that place. So we can take some of the lessons that we've learned from doing that on Earth and apply them to the space missions. It's just a lot more challenging with the engineering with missions. Any more burning questions? Keep them coming in. We've got a few more to have answered.
I just wanted to mention.
Oh yeah, go on now.
We saw the plumes coming out of Enceladus. Those plumes we think that they are also present in Europa, and those are made out of the water ocean that comes from underneath the ice layer. So one possibility of checking if there's life in those planets without contaminating it is by flying spacecraft through those plumes and checking if they contain life before they can be cooked or destroyed by the conditions of space.
So next question, how long would it take for you to get to Titan?
It's about 7 years, I think. So Cassini took 7 years to get there. So from the time that you launch, you've got 7 years, and then you carry out your mission. And then Cassini actually, how they kind of closed the mission or ended the mission is they flew the spacecraft into orbit around Saturn, and eventually it got like burnt up in Saturn to kind of destroy it. And like the previous question, try and prevent any contamination from this spacecraft to potential habitable environments like icy moons. So it'd take about 7 years to get back to Titan, depending how fast you go.
So what gas makes the orange color in Titan's atmosphere?
That's a really good question. And it's actually not that well known, I think. I mean, there's a lot of kind of ideas that people have. So I mentioned that methane is particularly common on Titan. It's the liquid that forms the rivers and lakes. So there's also a methane gas in the atmosphere. And a bit like as Al was mentioning, how the radiation cooks stuff on the surface of Europa that has no atmosphere. Radiation in Titan is actually just cooking the materials in that very upper layer of the atmosphere. And we think that what that does actually is do some chemistry, basically. So you take that methane and the radiation kind of cooks it and changes it and forms longer and bigger molecules that actually have that orangey color. So that's one of the ways we think that forms. Some of those molecules, those larger pieces of molecule, will rain down out of the atmosphere and actually form things like sand dunes and stuff on Titan. So really weird sort of alien landscape formed of this these sand dunes that have actually been formed in the upper atmosphere through this cooking by radiation.
Oh. So we have a question for you, Grace. What is the machine that you use called?
So there's I'm getting all confused now. What would I call it? I would say that I use a cryogenic vacuum system. And that is something that I've kind of put together. You get your container and then you put different things around the outside. So you get control systems to measure the pressure and the temperature and what's kind of going on within there. I have a camera system in there, but I would say that the whole piece of equipment that I use mainly is a cryogenic vacuum system.
I think you should name it. I think you should give it a name, a different name.
Maybe I should. I don't. If anyone has any good suggestions for naming my equipment, please put them in the chat. Give me some ideas.
So at Fieldhouse again, sent us another lovely question. What would potential life look like on one of these moons, do we think?
Anyone can go for that. Grace, do you want to answer?
What would life look like on these icy moons? I think you can really let your imagination run wild with this because we just don't know. Generally, when we're looking for life, we are trying to keep our expectations quite low. So we're looking for evidence of any past life, so any molecules or potentially fossils that could indicate signs of life there. Or we're even looking for the teeniest, tiniest little microbes that would show us that there is life there. But I think about this a lot and let my imagination really run wild. We think about life on Earth and it's so diverse and there's so many different kind of, animals, fungi, microbes, bacteria, like even if you look in your fridge, you've got like a little bit of mold on your yogurt or something. And then you've got your pet dog or cat. And then you've got, I don't know, fruit flies on your plants, So if you think about, especially what's in our oceans, you've got all these crazy like giant squid type things. And yeah, you can really let your imagination run wild. That's just on Earth. And then you think about what could be in an alien ocean, we don't really know.
And as Al was mentioning earlier, we have these oceans are so deep and there's so many different conditions within them that you could have a whole range of different types of life in different places. So you could have life that's adapted to live under that ice sheet where it's quite cold. And that could be very, very different to the stuff that's living way down at depth near the seafloor where it's a lot warmer and you have a lot more nutrients from the hydrothermal vents. And those two forms of life might to each other seem just as alien as we do to them. So these are large environments with a lot of potential for variety. But so whilst we let our imaginations kind of go to all kinds of places with this, we have to, as Grace said, when we look for life, what we're looking for is really the simplest building blocks that might provide evidence of life. So we're not going to go there looking for dolphins or sharks initially, or giant squid. We'll go looking for the kinds of signatures, molecular signatures, or various kind of fossils, things that might get left behind by all types of life.
I think as well, something that I'd add to that is if you're looking for signs of life on icy moons, compared to somewhere like Mars, we know that there's been, things that have been interchanged between Mars and Earth. So we find Martian meteorites on Earth. So potentially the life that we could potentially find on Mars would be similar to Earth. But there's no possibility of that actually happening with icy moons, or it's very, very unlikely. So any potential life that we do find on an icy moon has evolved completely separately to what we find on Earth. So really, you're kind of trying to expect the unexpected, but like keep your expectations quite low at the same time.
Yeah.
Oh, thank you, Grace.
A quick mention that here on Earth, light that comes from the sun is actually supporting some of the biggest animals in the ocean. I mean, whales basically feed on one of the smallest creatures that are found in the ocean, and all that life is sustained by the light that comes from the sun. In these ocean worlds, we don't have that light, so it depends on how much energy they are inside. So that's why we're starting low and then going bigger, starting with the microbes.
That's it. Start at the bottom and work our way up.
Yeah.
Well, Doesn't time just fly? Because unfortunately we are at the end of our hour. Thank you everybody so much for all your questions. I know we haven't got around to all of them, but if you look in the chat, there is an email address, stem-communications@open.ac.uk. If you want the experts to answer any of these questions, please put them in there or send them off to that email, and we'll all try our best to answer them for you. Now, one last thing before we go, let's have a look at the poll. Have we got our answers to can everyone see that? I don't know, but I will explain. So Enceladus got 26% of the vote, Titan got 60% of the vote, and Palm, poor Europa, only got 14% of the vote. So I think everyone obviously likes Titan the best. They're all with you, Mark.
Very good. I'll be packing my bags and coming with you all to Titan. Just bring something warm.
That's it.
Well, once we find life on Europa, that will change. The polls will change.
Well, thank you all of you very, very much for coming today. We're so glad you could join us. Thank you to all our team here. Thank you to our people.
Thanks, everybody.
Thank you. Bye.
Bye.
Bye.